Hi, today we're going to take a look at one-step equations and how to solve them using addition and subtraction. Let's start with this equation right here. X minus 3 equals negative 4. It's an equation because it has an equal sign in the middle, meaning that this side is equal to this side. Well, if x minus 3 is the same as negative 4, what would x be? How would we solve it? Well, we are going to take that 3, and if I do the opposite of subtracting 3, I would add 3. So I'm going to take this minus 3, I'm going to switch it. So stay, the x stays, switch subtraction to addition, switch the 3 to a negative 3, and now I'm going to try to get rid of the negative 3. The only way to get rid of a negative 3 is to add 3. Now, if this side is truly equal to this side, if I add 3 over here, then I need to add 3 over here. And if I add 3 to negative 4, I end up with a negative 1. So x must equal negative 1. Now, if I plug negative 1 in for x, I would get negative 1 minus 3 equals negative 4, or negative 1, I switched it earlier, so plus a negative 3 equals a negative 4. Let me show this to you with algebra tiles. This long tile right here represents x. The object of an equation is we're always trying to find the value of x. We're always trying to get x alone so that we can figure out what x equals. If I can get x on one side of the equation all by itself, and I have a number on the other side, then I can find what x equals. Well, this right here represents a balance, kind of like a seesaw. If I get on a seesaw and one of you gets on a seesaw, more than likely you're going to end up in the air and I'm going to end up down on the ground. If I get on a seesaw and somebody the exact same size as me gets on the seesaw, then we're going to balance it out. It's going to be equal. Well, right now, this seesaw is balanced. This scale is balanced. In other words, on this side, the weight is the same as on this side. So nobody's up in the air, nobody's down on the ground, okay? They're equal. So if I were to take 3 pounds off of one side, I would have to take 3 pounds off the other. If I were to add 3 pounds, I'd have to add 3 pounds to the other, okay? That seesaw stays balanced, okay? Our object is to keep this balanced, our equation balanced. So I have 1x minus 3. These red chips right here, these algebra tiles, represent 3 and a negative 3 because they're red, and then equals a negative 4. These are red, and it equals negative 4 on this side. Now, this is the right side of my seesaw, and the right side of the seesaw is the right side of the equation. The equal sign is like the fulcrum of the seesaw, or the middle part of the seesaw that holds the seesaw up. And the left side is represented by the x minus 3. Okay? So I am going to I'm going to try to get x all alone. X needs to be alone so I can figure out what x equals. So I'm going to add 3 to this side. So if I add 3, what's going to happen when I put a positive and a negative together? They are going to cancel out. 1, 2, 3. So when I add these 3, the negatives cancel out, and x is left all alone. Now, whatever I do over here, I have to do over here. So I need to add 3 to this side also. So I added 3 to both sides. When I add 3 to this side, 3 negatives also cancel out. So I can take those away. And I'm left with x on the left and negative 1 on the right. So x equals negative 1. Let's go over here and take a look at this one. Negative 5 minus n plus 2. Again, I'm trying to get the variable alone. The variable happens to be on the right side of the equation this time. Your variable could show up on the right or on the left side of an equation. But your object is always to get the variable alone. So to do that, I am going to take 2 from both sides. So let's subtract 2, which gives me 0 on this side, or just n. And whatever I do to the right side of the equal sign, I have to do on the left side of the equal sign. So subtract 2, and I get negative 7. So n equals negative 7, or negative 7 equals n. All right, let's go down here and look at it at the bottom. I have n plus 2 on this side, and I have negative 7 here. Oh, excuse me, negative 5 here. So negative 5 equals n plus 2. Well, I'm going to subtract 2 from this side. Since I have 2 positives, the only way to get rid of the 2 positives and get the variable alone is to subtract 2. So I'm going to take 2 away. I'm going to subtract 2. So to subtract 2, I'm going to add my 2 negative chips. Now negative and a positive cancel each other out. I can take this away. And whatever I do to one side, I have to do to the other. So I'm going to subtract 2 over here. Which leaves me with don't want to stay on the board. Which leaves me with n equals negative 7. Negative 7. There we go. We can see it now. Yay. N equals negative 7. A variable is a letter that represents a number. So it's a letter that you'll see in the place of a number. A variable could be any letter, A through Z. Pick a letter of the alphabet, you could find it in a math equation. Okay, I'm going to show you the meaning of the addition property of equality because we use it all the time when we're trying to solve equations. The addition property of equality says if you add the same number to both sides of an equivalent equation, then you will produce an equivalent equation. Okay, what does that mean? Let me show you. If A is equal to B, so if they're both the same, then if I add C to A and I add C to B, then my answer is still going to be equal. Okay, let me show you that down here. If x minus 5 is equal to negative 1, whatever I do to this side, I have to do to that side to keep them equal. So if I add 5 over here to get my variable alone, I'm going to add 5 over here. Well, negative 1 plus 5 is just 4. So on this side of my equation, I have 4, and on this side, I have x. X equals 4. You always want to go back and check your equations. Plug in 4 for x and rewrite the equation back out. I'm going to stay switch when I see a subtraction sign. That helps me. So 4 plus a negative 5, if I have $4 and I owe $5, I can pay off 4, but I still owe $1. Okay? So I can see that, yes, it is true, that it does work. Let's look at the subtraction property of equality. It's very similar to the addition property of equality, except this time it says that subtracting the same number from both sides of an equation produces an equivalent equation. For example, if A is equal to B once again, if I subtract C from A, then I also subtract C from B, then they're both still equal. Let's take a look at that. All right, if m plus 3/2 is equal to 1/2, then if I subtract 3/2 from the left side of my equation, and I like to always pay close attention to the left and the right side of my equation because this is like the left side of my seesaw and this is the right side of my seesaw and they're equal. So whatever I'm doing over here, I have to do it over here. Okay, so negative 3/2, if I take it away, that's going to cancel that out, that 3/2. And then if I take 3/2 away from 1/2, I'm going to end up with negative 2/2, which is just 1. So negative 1. So m equals -1. Well, let me try that out and see if it works. Always want to check it. I'm going to plug in -1 for m. -1 plus 3/2, which is the same as 1 1/2. So I'm going to go ahead and change this to 1 1/2, because 3 divided by 2 is 1 with a half left over, equals 1/2. Well, -1 plus 1 will just cancel out, and the half will be the only thing that's left, and that should be 1/2. So it's correct. It checks. Let's try the addition property of equality right here. Now, a question that I want you to be able to answer is, when will you use the addition property of equality? You're going to use it when you have subtraction in your equation, okay? So p minus 5, I'm going to always stay switch whenever I have subtraction. So I'm going to go ahead and switch both of these to plus a negative, plus a negative, okay? And what's the opposite of taking 5? Adding 5. So I'm going to add 5 to both sides. Adding 5 to a -5 will just cancel that out, and I'll be left with p on the left. And adding 5 to a -2 will cancel out 2 of these positives and leave me with 3. P equals 3. Now you want to always plug in your answer and see if it works. 3 minus 5 equals -2. If you need to stay switch, go ahead and do that. 3 plus a -5 equals a -2. Okay, let's go down and take a look at this one. X plus -5/6 equals -1/6. I'm going to add 5/6, and I'm going to add 5/6. This cancels out. I'm left with x on the left. And on this side, a -1 plus a +5 is going to leave me with a +4/6, which is the same as 2/3. So I'm going to go ahead and reduce that. Okay, x equals 2/3. Let's see if it's true. Plug 2/3 in for x. Okay, I'm going to check it right here. 2/3 minus 5/6 equals a 1/6, negative. Okay, I've got to get like denominators. So times 2 times 2. So 4/6, and I'm going to switch this, plus a -5/6 equals -1/6. I have more negativity than positivity, and when I put them together, I do get a -1/6. Let's go to subtraction property of equality. The subtraction property of equality, I'm going to be using subtraction to find my answer. So let's subtract 13.2 from both sides, and I get W equals, when you add a positive and a negative, ask which one has more. There's more negativity, and subtract. So I'm going to take 13.2 and take 10.4 away from it and see what I come out with. It's going to give me -2.8. Go back and plug it in, and when I do, I will see that I'm going to end up with 10.4 as my answer. All right, let's go to r plus 2/3 equals 1/2 or 1/5. I'm going to subtract 2/3 from both sides. I got to get a common denominator. R equals 3/15 minus 10/15, which equals -7/15. So R equals -7/15, and I want to go back and plug that in for R right here. So -7/15 plus 2/3, I'm going to go ahead and get my common denominator by multiplying by 5/5. 10/15. If I add 10/15 to -7/15, I have more positivity than negativity, and I'm going to end up with a positive 3/15. Which reduces to 1/5, which is what my answer was, so it checks out. All right, go ahead and pause it right here, and I want you to name the property, whether you use the addition property of equality or the subtraction property of equality to solve these, and then I want you to solve them. Okay, you should have subtracted 6, and you come out with m equals -10. plus 2 1/10 plus 2 1/10. And that's going to cancel out. And if I add a positive and a negative, I got to ask which one has more, positivity or negativity? There's more negativity. And I'm going to subtract. 5 minus 1 is 4. And 4 minus 2 is 2. So D equals negative 2 and 4/10. Q plus 1/4 equals 4/5. I need to subtract a fourth from both sides. Okay, got to get a common denominator to do this. 20 is the least common multiple. So I get 16/20 minus 5/20, which leaves me with 11/20. So Q equals 11/20. And if I plug in 11/20 for Q, I end up with 11/20 plus 5/20 is what this becomes when I get common denominators, which is 16/20, which reduces to 4/5. So it works. Last one, number 4. F minus 1 1/3 equals 2 3/4. I have to add 1 1/3 to both sides. Okay, this would cancel out. I end up with F equals, I got to get common denominators here. The least common multiple of 3 and 4 is 12. So I get 2 and 9/12 and 1 and 4/12. And when I add them together, I end up with a 3 and 13/12. 13/12 is improper, so that's going to become, 4 and a 12. And if I plug 4 and a 12 in for F, let's see what happens. 4 and a 12th minus 1 1/3. I'm going to go ahead and change that so I have like denominators. So 1 and 4/12 is what this would become. Minus 1 and 4/12 equals, I'm going to need to change these to improper fractions. 48/49/12 minus 16/12, which is going to give me 33/12, which equals 2 and 9/12, which reduces to 2 and 3/4, which was our answer up above.